In this lesson, we're learning about critical path. Let's start by considering the example of starting a small business. There are a number of tasks which need to be completed before you can launch your business. You want to prepare a business plan, conduct market research, find partners, a location, analyze the market research, evaluate your product distribution system, arrange financing, and then finally launch the company. So based on this information, we want to know, when will the business launch? If we have many tasks that are necessary to complete a project, and some of the tasks can be carried out simultaneously, we can use graph theory to determine the minimum amount of time necessary to complete the project. A critical path, or the minimum amount of time to complete all steps, is the simple path of maximum value. So we've talked about simple path and maximum value in previous lessons. So a simple path is a path that does not repeat any edges, and the maximum value is the path with the highest value of all the weighted edges. There are 5 keys to determining a critical path. First of all, you're going to have vertices that are the steps in the project. Each edge is weighted with the time it takes to complete the step, using the vertex as the start of the line of the edge. So for example, we have A, it's got an edge that goes along with it, and there will be a weight associated with it. Typically, that's going to connect to another vertex. So we're saying the time it takes to get from A to B before you get to the B task is 5, whatever units, whether it's days or minutes. However, if you've got another task that can't be started until A is complete, you put in another edge which connects to that vertex as well, and it has the same weight, of course. So think of a task as both the vertex and the weighted edge that goes along with it. And in some cases, there may be multiple weighted edges that show the relationship between that task and a task that follows it. So you're going to use all of the steps that are part of a project to create a path. And then you'll find all the possible simple paths from the start of the project to the end. Once you've found all the possible simple paths, you choose the longest path. That gives you the critical path for the project. Let's return to the starting a business example. Remember, we're looking for the critical path through the tasks that need to be completed. So again, here's our complete task list, and let's start mapping it out. It tells us that the first step is to prepare the business plan, and it's going to take 30 days. So I've got an edge, and it's given a weight of 30. I need to look through the list and see which other tasks can't be started until task A has been completed. So I look down here where it says prior steps. I see that steps B, C, and D all need to have step A completed before they can begin. So I have to have B, C, and D, and they're all going to have connections to A, and they will all have the same weight of 30. Now I look at B task, it's got a weight of 10, and then I look to see which task can't begin until B has been completed. And from the list, I see that here it says task B is a prior step, and that's related to task E. So I put task E up, and I connect it to B, and it tells me that the weight of B was 10. Note that the length of the lines is irrelevant. You can see each of these 30 lines are different lengths. It's really just showing a relationship, and as long as you have the correct weight number associated with that edge, then it's representing the graph correctly. From step E, I look to see if there are any steps that are dependent on E being complete. And so I look down my list and I see that step G requires both E and F to be complete. So I'm going to put G out here and connect it with an edge, E to G, and I look at step E has a weight of 5. Now I get to step F. Step F is dependent on C and D being completed. So I have edges going from both C and D going to F. And what's the weight associated with C? It's 25. And weight associated with D is 20. Looking at vertex G, so step G, it's got a weight of 35. It's dependent on both E and F. We've already got E in place, so I'm going to go ahead and map in F and put in its weight, which is 15. And then step G, the only one dependent on it is step H. So I can go ahead and connect them and give it its weight of 35. So at this point, I've got a graph that represents all of the tasks and the relationships from start to finish, from step A to step H. Now my next step is to go through and look at each of the possible paths to see which one gives us the longest path. I'll start off with A to D, D to F, F to G, and G to H. If I add them up, I've got 30 and 20 is 50, plus 15 makes 65, plus 35 makes 100. So path ADFGH has a weight of 100. Let's look for another path. A to C, C to F, F to G, and G to H. 30 plus 25 is 55, plus 15 is 70, plus G to H is 105. And the final path through the graph, ABEGH, is 30 plus 10 is 40, plus 5, 45, plus 35 is 80. Now we can look at the weights of all of the paths, and it's fairly straightforward to see that ACFGH has a weight of 105. That is the largest value. So we can say that ACFGH is the critical path. Therefore, the minimum time to launch the company to go from start of the process to the end of the process is 105 days. Try this question on your own, then come back to check the solution. An accounting firm hires a company to review its computer system. The following is the company's proposal for the implementation of the new system. Determine the minimum amount of time necessary to implement this system. The first step in our process is to identify all the steps and start creating the graph. We're doing our analysis of needs. It takes 10 days, and only step B is dependent on that. So we can go ahead and put those two out, connect them, and put in the weight of 10. Now, steps C and D are both dependent on step B being completed. Step B is 8 days. Step E and F are both dependent on step C being completed. And step C is 21 days. Step G depends on both E and F being completed. Now I need to assign the weights from E and F. Step E gets a weight of 6, and step F gets a weight of 18. Step H is dependent on both D and G. Adding in the weights for step G is 5, and for step D is 3. Final step, step I is only dependent on step H being complete. Put in step H along with its weight, which is 4. Now we look for the maximum path through the graph. We'll start with the first most obvious path, ABCEGHI, which is 10, 18, 39, 45, 50, 54. Let's look at the next possible path. We started off the same, 10, 18. Step C is the same distance again, 39, 57, 62, 66. And the final path through, adding them all up, 10 plus 8, 18, 21, 25. Remember, with critical path, we're looking for the longest time. In this case, it's ABCFGHI with a weight of 66. We summarize to say the time to complete the computer work is 66 days.